is the red stripe mean that these are now the commander? That's an Apollo joke for, okay, sorry. Thank you, Sarah, I appreciate it. So it's my honor and privilege to co-chair this session, community updates and upcoming missions. We've got our first presenters online. We're going to start in T-minus 1 minute. Co-chair is Steve West. Say hi, Steve.
Oh, hello.
Good job.
Thank you.
You're going to do great in this position. We are going to have a discussion session starting at the end of the session, of course. So the speakers will have 15 minutes. We'll give a signal when you've given 10 minutes. We'll give another signal when you're at 2 minutes left, and try to wrap it up. Good luck keeping me on time, by the way.
Oh, dear.
Yeah. With that said, Steve, take it away.
So our first presenter this morning is Victoria Friedensen. This is an invited talk.
Good.
And she'll be speaking on NASA's Planetary Defense Coordination Office and giving us an update. So Victoria, if you're online, the stage is yours.
This is Lindley Johnson at headquarters. We can barely hear you. Can you hear me okay?
We can hear you. We can hear you. And I think we'll have mics in the room for Q&A. So hopefully that will be able to hear those questions as they come in.
Okay, you came in much better than it was really almost unreadable before. But if you're ready for me to get started, I will do so.
Yes, you can go ahead and get started. Thank you.
Okay, let me drop that off the screen. Okay, well, I'm Lindley Johnson, the Planetary Defense Officer at NASA headquarters. I think most of you know me, and probably many of you have seen some form of this briefing as I've given it updates to various forums around the country. But let's just get into it. For those of you that may not be familiar with the Planetary Defense Coordination Office, it was established early last year. Officially, although we've been doing work in this area for 18 years or so now. But our mission is to lead both national and international efforts to detect any potential impact of planet Earth by natural objects, figure out if there is a potential impact, what the effects could be from that event, and then help the nation develop strategies to mitigate those impact effects that they might have on population and infrastructure. I'm not going to read through all these, but these are the areas of responsibility for the Planetary Defense Coordination Office, ranging from, first of all, detecting what's out there and determining if anything is a threat to the Earth, provide timely communications up through the U.S. government of any potential impact, and then also getting it out to the international community as well, and working with the U.S. Within the U.S. government and the interagency to develop what our response would be to such a event. Some of you may be familiar with what is called the OODA loop. OODA is simply an acronym for a process to handle any potential problem or activity, endeavor. It stands for the words observe, orient, decide, act, and assess. So the Planetary Defense OODA loop follows this construct, but we use slightly different words. We detect objects, we follow them up to determine if they could be threats to Earth. We characterize that population so we know what it is we're looking at, size, composition of those objects. If one is a threat to the Earth, then we need to plan what our response to that is going to be. What are we going to do about it? And then there's also a very vital step, both nationally and internationally, to coordinate that response so that everybody gets on the same page, so to speak, as to what's going to be done. Then actually implementing a mitigation activity, be it on the Earth or in space. And then assessing the success or lack thereof of that response, and then back into the cycle again. And so the Planetary Defense Coordination Office is at the center of this activity. I guess you could say that we are the grease to the wheel of the OODA loop for planetary defense. And so all of our projects that the Planetary Defense Coordination Office supports, both in NASA and universities and institutions around the country and with other government agencies, fit in some spoke of this wheel. And I show that here. You see the predominance of our endeavors are certainly in the detection, follow-up, and characterization, because that really is the most important thing to do, the highest priority. If we can't find them and know what they are and what the threat is, we can't do anything about them. But in more recent years, we've also had a lot of activity in the other areas as well, and that is a growing part of our business. Speaking of growth, our detection capabilities of near-Earth asteroids has grown over the years as we've gotten additional funding and been able to upgrade what is largely our ground-based assets right now. So in last year, in 2016, almost 1,900 near-Earth asteroids were added to the catalog. Over the last 3 years, we've had about a little over 80% increase in our detection of near-Earth asteroids. And this year, we're on track to meet that level of detection. We have almost 900 so far as of the middle of July. So I think we will meet or exceed the almost 1,900 that were found last year. So overall, cumulative catalog, we are now at over 16,000 near-Earth asteroids in the catalog. We also have 106 Earth-approaching comets. Of those, 140 meter and larger, which is actually our current direction from Congress to find all the near-Earth asteroids larger than 140 meters in size. A little under half of the catalog is on the larger size. But 1,821 are what we call potentially hazardous asteroids. Those are the ones that come within 5 million miles of the Earth and therefore could migrate into Earth crossing orbits. Of the large size, 1 kilometer and larger, 879, and 157 of those come, their orbits bring them within 5 million miles of Earth's orbit. So where are we at in reaching the goal that Congress has set out for us, finding 140 meters and larger? The estimated population of those is somewhere between 24 and 25,000. So if they were to find 100% of that population, currently we've almost found all of the 1 kilometer and larger. We are about 93% complete for 1 kilometer and larger, but that's only about 4% of this 140 meter and larger population. 300 meters to a kilometer in size represents about 22% of the population. We are a little over halfway through that portion of the population. So most of the work remains to be done in the smaller sizes. 140 to 300 meters in size is almost 3/4 of the population we need to find, and we still have about 60% there to find. So between the smaller sizes and the mid-size range, we have about 70% yet to find of this population that we've been tasked with. We have been working with the international community, certainly, both bilaterally and through the United Nations. The near-Earth object threat has been a topic of discussion within the Committee on Peaceful Uses of Outer Space for many years. And in working with the NEO working group, a regime has been set up, so to speak, as to how nations can work together to address this threat. The parent governments that are representatives to the Committee on Peaceful Uses of Outer Space have agreed to set up two organizations to address this. The first is the International Asteroid Warning Network, which is all the observatories, orbit analysts, and modelers to detect, track, and characterize the potential threat. And then a parallel and would inform through the parent governments and to the United Nations if a credible impact threat were detected. And then the parallel organization is the Space Missions Planning and Advisory Group, the so-called same page, and this is a forum for the space agencies to work together, coordinate their activities on technologies and techniques that could be used in response to a detected impact threat. The IWAN and same page have been working together to develop their criteria and thresholds for when activity should begin, first of all, for warning of an impact, and then for initiating mitigation activities if it is a impact of a severe enough effect that we need to try to do something about it. I won't read the details there, but it'll be in your records for going back to look at. Another activity that PDCO has been involved with is the Interagency Working Group here within the U.S. government, Interagency Working Group for Detecting and Mitigating the Impact of Earthbound Near-Earth Objects. That's a mangled acronym if ever there was one, but it all results in DAMIAN. And this is under the Committee for Homeland and National Security within the National Science and Technology Council. The goals for DAMIAN were to develop a preparedness strategy for the U.S. government and follow that by a preparedness action plan to be in better position to address this potential hazard. So that was formed just a little over a year ago, and our first task, of course, was to work on the preparedness strategy. And who says government can't move fast? That preparedness strategy came out at the end of last year in December, and so that is now our guiding document to begin efforts on the action plan, which are just now being taken up again with OSTP and the interagency group. One of the things that was laid out by the strategy is our planetary defense timeline, which we talk about activities that are to the left or to the right of boom, so to speak, which in this case is the impact. And what do we need to do to prepare to be able to do things before the event and hopefully avoid it or at least minimize the impact of the event versus what has to be done for recovery response to such an event. Of course, there are a number of overlying activities and capabilities that are needed that are important to all phases of this timeline. But then there are activities within this preparedness strategy to focus on detection, characterization, and tracking. Then the in-space mitigation activities, deflection and disruption activities that would take place years to maybe weeks if it's a short notice warning. And then the emergency response domain, which is short-term activities that would have to take place before a predicted impact, like evacuation and those kinds of things, protection of infrastructure, and then the recovery from such an event. So we work with the Federal Emergency Management Agency, of course, a lot in this domain, and have had activities with FEMA these last few years to work out with them what they need to be prepared for to respond to. And this last year, one of those activities was our emergency response exercise number 3 with FEMA Region 9 out there in California, as a matter of fact. And we had participation by the Governor's Emergency Services Office as well as the U.S. Air Force, FEMA here, and Planetary Defense Coordination Office, and supporting that technical expertise from JPL and the Department of Energy National Labs. And a report of this exercise is due out any day now. So in looking at planetary defense, our decadal survey, so to speak, equivalent of a decadal survey, is a National Research Council report from 2010 that looks at these activities and what was the most viable response. There is no one silver bullet, so to speak. It depends on the scenario, so that we need to think about a toolbox of capabilities for mitigation of a potential impact. The most mature and I believe to be effective given current technology are capabilities for a kinetic impactor. We think this is the most mature and probably would be the most effective, except for very short warning times. Also, the technology that we have today allows us to develop what we would call a gravity tractor. And you can find the details of these kind of capabilities in the report, but we are working on these efforts to develop into demonstratable capabilities. So projects that the Planetary Defense Coordination Office is undertaking to get into development in the near term are, first of all, increase our detection capabilities to get a better handle on that population that still needs to be found. The NEOCAM, this was a discovery proposal, which we have done an extended phase
Lindley?
A effort to redefine it as a planetary defense mission, and it completed a Delta mission concept review here just end of June. And the double asteroid redirection test to test the kinetic impactor capability has just been approved
Lindley?
here, phase B. Yes.
I'm sorry to cut in. We are at time, unfortunately, so if you can perhaps wrap up with a quick remark, and we'll have the discussion session at the end, and I believe if you'll be on for that, we'll have time for questions then, but I'm sorry we need to get on to the next presentation.
Sure. Well, let me just say one last thing. We have a observation campaign this fall to test our assets and capability for detecting close approaches and characterizing them. Object 2012 TC4 will be approaching the Earth in October, may come within the geosynchronous belt of satellites. So we'll be working with our assets to develop that capability. The last thing I wanted to show here is just a perspective of TC4 as it approaches the Earth. Here on a spacecraft that's following TC4 in. Imagine you're there and you see it tumbling in front of you here. As it approaches the Earth, that mass up there of text is all the Earth orbiting satellites. As TC4 comes in, approaches the Earth, it passes under the Earth and then comes up and may pass within the geosynchronous belt. Latest activities show that it may actually stay under the geosynchronous belt, but this is the kind of thing that we need to be concerned about as these small objects come close to the Earth. And with that, I am done.
Well, thank you very much, Lindley and Victoria. We'll have time for questions at the end of the session at 9:55. So now we'll move on.